Where we begin with probability is trying to define a sample space. Sample space is all possible simple events that could occur. So in the board game of life, you spin a spinner numbered 1 through 10. The spinner goes around, hopefully it's equal, and it has an equal chance of landing on 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. For that reason, when I list the simple events in the sample space, I start with my brace to say a set's beginning, then I list the first possible event 1, I put a comma, the next possible event 2, I keep going until I've listed every possible event, everything that could happen when I spin the spinner. Now that I've listed all 10 possible events, I have the complete sample space. When it asks me to list the events in A when A is spin a 7, there's only one event that fits spin a 7. That's the 7. When B says spin an odd number, there's 5 events that fit that event. So that would be rolling a 1, spinning a 3, spinning a 5, spinning a 7, or spinning a 9. For number 4, list the events in C that are less than 3. To be clear, 3 is not less than itself, so it's not included. The ones less than 3 then are 1 and 2. For number 5, list the events that are greater than 5. Again, 5 doesn't count because it's equal to 5. So we start at 6, which is bigger. Then we have 7, 8, 9, and 10. For the next section, it tells me to use the following for 6 through 8. It gives me a sample space that are events listed E1, E2, E3, E4, E5, E6, and E7. It tells me that the ones that are in set A are E1, E2, E3, and E4, and the ones that are in set B are E1, E3, E5, and E7. First thing it asks me is what's in both A and B. This is an intersect question. The only things that count are things that appear both places. So E1 is in A, E1 is also in B. That counts. E2 is in A, but it's not in B. It doesn't count. E3 is in A, it's also in B. It does count. E4 is in A, but it's not in B, so it doesn't count. Similarly, E5 is in B, but it's not in A, so it doesn't count. And E7 is in B, but it's not in A, so it doesn't count. So for this type of problem where it says both, I'm only going to put in the set the things that occur in both of them. E1 and E3. When you go to enter these into Cengage, it's a little tricky. You need to click the math type button on the right side of the page. That'll let you select something with a subscript where it looks like a box with a little box underneath. You put the E in the big box, you put the 1 in the little box, and then you have to press your cursor over to get out of that little box. It's definitely something that's tricky the first couple times you use it, but once you figure out how the system wants you to input things, it's really not so bad. For question 7, it says A or B or both. When I do this question, I start by writing everything in A. So A includes E1, E2, E3, and E4. All of those definitely count. Then we look for things in B that we haven't already counted. E1 has already been counted, we don't need to double count it. E3 has already been counted, we don't need to double count it. E5 is new, and E7 is new. So both of those were not included in A, but they were in B. When we do A or B or both, we include everything here and everything here except with the overlap. So we end up with E1, E2, E3, E4, E5, and E7 when we have A or B or both. Another way of saying that is A union B. When we get to not B, that's the complement of B. Basically what we're doing is comparing the sample space to B. Anything that is in the sample space but's not in B is in the set not B. So E1 is in B, it doesn't count. E2 is not, so E2 goes into my set not B. Similarly, E4 and E6 are not in B. So again, to find not B, all I'm really doing is comparing B to the sample space. Anything that's in the sample space that's not in set B goes into not B or the complement of B.